Welcome to section 4.1, Basic Concepts of Probability. We're going to be interpreting probability values, and we're going to find probabilities, and then we're going to discuss odds in this section. So here are the concepts, and let's get started. So the basics of probability, we have an event, which is a collection of results or outcomes. There can be simple events and events that are not simple. If an event is simple, it cannot be broken down any further. So for example, rolling a 2, it's not like you could get 2A or 2B, you can just get a 2 or not a 2, and there you go. The sample space for a procedure consists of all possible simple events. So if a not simple event would be rolling an odd number, because you could also get a 1, 3, or a 5. So a sample space breaks down that odd number into 1, 3, and 5. And we're going to do an example. So consider a single birth and 3 births. Is either event simple or not simple? So a single birth, what are the outcomes of a single birth? Well, for a single birth, we could get a girl or a boy, and we can't really break it down any further. But with 3 births, we could, let's say we got a girl and a boy, or excuse me, girl and 2 boys. Well, it could be a girl and a boy and a boy. It could be a boy, a girl, and a boy. It could be a boy, and then a girl. So this is not simple because there's so many different other outcomes within that this one is not simple and the single birth is simple. All right, let's list the sample space. So a sample space lists all possible outcomes, all of the simple events. So for a single birth, the sample space is going to be a boy or a girl, right? That's all that could happen. So the sample space is boy, girl. 2 outcomes. It gets a little trickier for 3 births. So let's take a look at the sample space for 3 births. So let's just say, okay, for kid 1, you could have a boy or a girl. For kid 2, well, let's say you had a boy first, you could have a boy again, or you could have a girl. If you had a girl first, you could have a boy or a girl. All right, what about kid 3? Well, that could be a boy or a girl. That could be a boy or a girl. That could be a boy or a girl. And that could be a boy or a girl. So we kind of follow it along. One of the options would be boy, boy, boy. Another would be boy, boy, girl. Another would be boy, girl, boy. And hopefully you kind of see how I'm getting these boy, girl, girl. Then over here would be girl, boy, boy. And then girl, boy, girl. Girl, girl, boy. And then girl, girl, girl. And that is the sample space. 1, 2, 3, 4, 5, 6, 7, 8 outcomes. There it is again. And you give it a try here, listing the sample space for having 4 births. Here is my tree diagram, and this here is the sample space, all of those different outcomes. So we denote probability with a capital P. A, B, and C are events, and we say P of A, or the probability of event A occurring. We use that notation. Probabilities are always between 0 and 1. That's super important. You cannot have a negative probability. And so if you're thinking of percents, that's not the probability itself, that's the probability expressed as a percent. We usually use fractions and decimals for probabilities. 1 is certain, that relates to the 100%. And then 0 is impossible, 0%. 50, 50, likely is like 90, unlikely is like 10 or 5. And it gets a little hard to discern between after 0 and 1 and 50, 50. What this says is 0 and 1. We are between 0 and 1. All right, so if a year is selected at random, find the probability that Thanksgiving Day in the U.S. will be on a Wednesday. So we want to know the probability that Thanksgiving will be on a Wednesday. Well, what is the probability? That's never going to happen. It's impossible. It's a 0. Find the probability that Thanksgiving will be on a Thursday. So Thanksgiving on a Thursday. Well, that always happens, so the probability is a 1. And that's for those of you who like to read a little bit more. You go ahead and give these 2 a try. And there's the solution. So we're going to be talking about 3 different probability approaches today. Relative frequency using the past, classical or equally likely, and subjective. So with a relative frequency approximation, we're using the number of times it already happened over the total amount of times that it was repeated. Equally likely is when we know that something is equally likely to occur, boys versus girls, 50-50, or 1 out of 6 for your rolling the dice. And then subjective probabilities are estimations. Just try to be exact when you're expressing probabilities, the exact fraction or decimal to 3 digits. All right, we're going to do several examples here. In a recent year, there were about 3 million skydiving jumps and 21 of them resulted in deaths. Determine what type of probability approach and why. All right, so we're dealing with information that was already gathered in the past. So this is relative frequency because we're using the number of times that already occurred. So to find the relative frequency, we would say, okay, the probability of skydive death, lovely, right, is the number of times it happened over the total that they determined. So that would be 21 over that 3 million. And so the probability of a skydive death is let me get all the zeros, 1, 2, 3, 4, 5. 2, 3, 4, 5. That is the probability of dying from a skydive jump. So let's look at example 4. When 3 children are born, the sample space is as followed, which we already did. If boys and girls are equally likely, ding, 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 then those 8 simple events are equally likely. Assuming that boys and girls are equally likely, find the probability of getting 3 children of all the same gender when 3 children are born. Well, what type of probability is it? It's classical or equally likely. They told us that. All right, so find the probability of getting 3, and I never like to put numbers inside probabilities because that confuses me. 3 kids, same gender, and it might confuse you too. Like if I put a 3 in there, you might kind of bug out. Like you might think it should be 3, which actually might end up working out. So how many times do we get all the same gender? Is it 3 times? No, it's actually 2. 2 over the total, which is 8. Simplify it, 1 over 4, or 0.25. All right, you give these 2 a try and press play when you're ready to see the answer. And there you go. Okay, I'm going to do one more before you try another. So what is the probability that the next dollar bill you spend was previously spent by Katy Perry? Determine what type of probability approach and why. This is going to be subjective because I really have no concrete data. Nobody's calculated how many times people touched the dollar bill before me. I really have no idea. And so when I try to find the probability that it's Katy Perry money, I really have no idea. Maybe I could say 1 in a million, but I don't actually know. And that's kind of subjective data. And that's the answer. Subjective data is an estimation. So you try this problem here. And the answers will vary. All right, let's do an example. And then another you try. So in a study of U.S. high school drivers, it was found that this many students texted while driving during the previous 30 days, and this many did not text during that same time period. Based on these results, if a high school driver is randomly selected, find the probability that he or she texted while driving during the previous 30 days. All right, so we want to know, we're looking for the probability that they texted. So we want to know the number that texted over the total. And this is where a lot of people make some mistakes, which is we need the total and they didn't give it to us. This is how many texted and did not text. So our total is adding these 2 numbers together. And our total is 8505, and the number that texted is this 3785. When I divide those 2 numbers, I get 0.445, and that is the probability. Go ahead and give this one a try. And there you go. Sometimes none of the approaches can be used, and we have to kind of create a simulation to figure out the probability. And then the law of large numbers says that if as a procedure is repeated again and again, the relative frequency probability tends to approach the actual. Remember that relative frequency is in the past, and so if we keep repeating it over and over, it might actually tell us something about what's actually happening. And that's going to conclude part 1 of section 4.1.